Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC B1C61 pertains to an abnormal low current detected in the driver's seat heater circuit of the 2011 to 2017 Honda Odyssey. This signifies that the seat heater control unit isn't receiving appropriate current to operate the seat heater system effectively. The seat heater control unit plays a critical role by regulating power to the seat heater and ensuring the seat core temperature remains safe and functional. Notably, the system will not initiate heating unless the seat core temperature is below 85 degrees Fahrenheit. Understanding this temperature threshold is essential for troubleshooting, as it sets the stage for proper diagnostics. Before beginning any tests, ensure the seat core has been sufficiently cooled to the required temperature. The error code B1C61 specifically implicates the driver's seat heater control unit, which is typically located beneath the driver's seat. This component operates by controlling the flow of electricity to the heating element in the seat, ensuring comfort for the driver when activated. It is designed to monitor temperature and prevent overheating by allowing heating only when the seat core temperature falls below 85 degrees. The data indicates that the issue arises when there's insufficient current flowing through the circuit, potentially indicating an open circuit or high resistance within the wiring. Hence, the physical location and function of this control unit are critical for effective troubleshooting, as any wiring issues along its path can contribute to this particular DTC. When diagnosing DTC B1C61, several possible causes must be considered. An open circuit in the wiring may result from damaged, frayed, or disconnected wires, preventing current flow from reaching the seat heater. High resistance at connections can be due to corrosion, dirt, or loose connections, again limiting electrical flow. Additionally, a faulty seat heater control unit cannot regulate power correctly and may falsely indicate a low current condition. Each potential cause offers a unique avenue for troubleshooting, requiring specific checks to ascertain where the underlying issue lies. It is imperative to systematically examine each of these areas to pinpoint the exact nature of the fault. Symptoms associated with DTC B1C61 prominently include a non-functional driver's seat heater, meaning the seat does not provide any warmth when activated. Drivers may notice illuminating warning lights on the dashboard, indicating a malfunction in the heating system. Additionally, there could be no observable heat output from the seat even when the control switch is engaged. These symptoms collectively affect the comfort and usability of the vehicle's driver's seat, prompting immediate attention for resolution. Recognizing these signs helps in efficiently identifying a failure in the driver's seat heating system and contributes to effective diagnostics. The first step in troubleshooting DTC B1C61 involves clearing any diagnostic trouble codes using the Honda Diagnostic System, HDS. This tool provides vital information and ability to reset the vehicle's onboard diagnostic system. By clearing the codes initially, you ensure a fresh start for the diagnostic process, which allows you to identify if the error is persistent or a result of an intermittent electrical fault. The HDS is specifically designed for Honda vehicles and will facilitate access to the vehicle's systems to monitor for current issues. This initial action is crucial as it prepares the diagnostic environment for further steps. In the second step of troubleshooting DTC B1C61, the ignition switch must be turned to the lock position and then returned to the on position. This cycle allows the vehicle's electronic systems to reset and enables the seat heater control unit to reinitialize its processes. It helps ensure that any temporary anomalies that may have contributed to the DTC are potentially resolved, This action is part of the standard diagnostic procedure and is necessary for accurate testing of the components involved in the heating system. A proper ignition cycle can help re-establish communication between the control unit and other electronic components. After cycling the ignition, the next critical step is to check for diagnostic trouble codes again using the HDS. This check determines whether the DTC B1C61 reappears after the reset and the ignition cycle. If the code is indicated again, it means that the problem persists despite the initial clearing, pointing to a more persistent electrical issue within the system. On the other hand, if the code does not show up, it may suggest an intermittent failure, implying that the circuit is operational at that moment. This step is essential in identifying the stability of the issue and aids in determining further troubleshooting strategies based on the results. In the fourth step of troubleshooting, you will again turn the ignition switch to the lock position. This is essential for safety before handling electrical components. Once the ignition is locked, the next action is to disconnect the driver's seat heater connector A, commonly referred to as a 5-pin 5P connector. This connector is crucial as it links the seat heater control unit to the heating element in the driver's seat. By properly disconnecting this connector, you can isolate the issue and perform further tests on the circuit without risk of electrical shock or triggering additional codes in the vehicle's system. This disconnection prepares the system for later steps that involve testing resistance and current flow. The fifth step involves connecting a jumper wire to terminal number 2 of the driver's seat heater connector A, 5P. This specific terminal is essential for testing purposes, as connecting it to body ground creates a controlled testing environment to evaluate the power flow from the seat heater control unit. By grounding this terminal, you can simulate the conditions required for the heater to activate. This step helps determine whether the seat heater control unit is functioning correctly and whether the wiring leading to the seat heater is intact. Proper execution of this connection ensures accurate readings in subsequent steps and is crucial for a comprehensive diagnostics process. Upon securing the jumper wire connection, the next step is to turn the ignition switch to the on position, I2. This action powers up various electrical systems and allows the seat heater control unit to acknowledge that there's a grounding situation at terminal number 2. Subsequently, clear the diagnostic trouble codes again using the HDS. By clearing codes at this stage, you ensure that any new fault conditions can be effectively captured for analysis. This process is pivotal for confirming that the system is set to reevaluate its current state and functionality. Following this procedure correctly allows for proper monitoring of the driver's seat heater system in response to the jump on terminal number 2. The seventh step involves checking for the DTCs using the HDS once more after performing the previous actions. If DTC B1C61 is shown again, it suggests that there's an open circuit or high resistance within the wiring that connects terminal number 2 of the driver's seat heater connector A, 5P, to terminal number 1 of the seat heater control unit, referred to as a 14P connector. This finding indicates that, despite grounding the terminal, the circuit has not resumed normal operation, warranting further investigation and repair. An absence of this code may imply that the jumper wire temporarily bypassed an issue. Hence, this verification step is essential to confirm whether wiring integrity or component malfunction requires repair or replacement. If DTC B1C61 reappears upon checking, the next step is to address the issue of an open circuit or high resistance in the wiring located between terminal number 2 of the driver's seat heater connector A, 5P, and terminal number 1 of the seat heater control unit, commonly referred to as the 14P connector. Open circuits can result from broken or frayed wires that disrupt the flow of current, while high resistance may occur due to corrosion at connections or faulty terminals. It's crucial to visually inspect the wiring harness for any signs of damage, ensuring connections are tight and securely fastened. Repairing or replacing faulty sections of the wiring will help restore functionality of the seat heater system, eliminating the electrical discrepancy indicated by the DTC. In the final troubleshooting step, measure the resistance between terminal number 2 and terminal number 5 of the driver's seat heater connector A, 5P. Evaluating this resistance is essential to confirm the integrity of the wiring and ensure that the seat heater system will function as designed. If there is high resistance or an open circuit in this measurement, it suggests underlying issues that must be rectified before affirming the system's functionality. Proper resistance levels indicate valid electrical pathways, ensuring that current can flow freely. Any anomalies in resistance values prompt further investigation and potential replacement of components. This final measurement is crucial in verifying whether all repairs have ensured the heater circuit operates correctly, leading to successful resolution of the DTC. After conducting the necessary repairs, the final verification step is to recheck for any diagnostic trouble codes using the HDS. This essential approach ensures that the resolution implemented has successfully cleared the issue and that the DTC B1C61 no longer indicates a problem in the system. Additionally, confirm that the driver's seat heater is operationally functioning, responding adequately to its control settings. Testing the heater in various conditions will determine if it activates and maintains temperature as expected. Successfully passing this check would indicate that all previous symptoms have been resolved and validates the integrity of the repair work performed. Ultimately, this step solidifies the assurance that the driver's seat heater system is back to optimal performance. Preventive maintenance is paramount for ensuring the longevity of the driver's seat heater system and can help avoid future occurrences of DTC B1C61. Regular inspections of connectors, especially the driver's seat heater connector A, 5P, and the associated wiring are vital to catching early signs of wear or damage. Cleaning any corrosion that appears at connections is crucial because corrosion can increase electrical resistance, leading to faults. Additionally, verify that wires are routed properly, avoiding friction with moving parts, which could lead to future failures. By incorporating consistent checks and maintaining clean, secure connections, the system's reliability is enhanced, thereby minimizing possible disruption in the driving experience. Proactive measures represent the best approach to vehicle maintenance and longevity. In conclusion, DTC B1C61 signifies an abnormal low current in the driver's seat heater circuit, primarily linked to the seat heater control unit and its wiring. Understanding the core components involved, such as connectors and wiring integrity, is essential for effective diagnostic troubleshooting. The step-by-step approach helps ensure that all potential causes, including open circuits and high-resistance conditions, are thoroughly examined and addressed. Proper verification after repairs guarantees not only the resolution of the current issue, but also reinforces the functionality of the heater system for future use. By employing preventive maintenance strategies, vehicle owners can further safeguard against similar issues, promoting a comfortable and reliable driving experience. Please like and subscribe to the channel. See you next time!